An interesting classification of groups, point groups, is called polar groups, and that relates to an interesting property called pyroelectricity. Pyroelectricity, as I have written the definition here, is development of electric dipole moment delta p, which is a vector quantity delta p, due to change in temperature delta T. So, the two are related by this vector equation delta P is equal to K times delta T, where K is the property, K is the material property. So, it is a material property which is a vector. Now, let us take two examples. The question which we want to answer is that what point groups will support pyroelectricity and what point groups will not support pyroelectricity. Means that in some point groups pyroelectricity can develop, but some point groups exclude the possibility of development or exhibiting this property. So, I take two examples from both. For a simple example from the monoclinic point group. Point group 2 has just a two-fold axis, and if I consider the possibility, let us consider the possibility of developing pyroelectricity along a direction which is perpendicular to the two-fold axis. So, let us say that a moment P is generated in a direction perpendicular to the two-fold axis, but because of the crystal symmetry, because of the point group symmetry, a dipole moment will also be get generated in a direction 180 degree rotated about the two-fold axis, and that, as you can see, will be an exactly opposite vector, and so these two dipole moments will cancel each other. So, there is no possibility of developing dipole moments in a direction perpendicular to the two-fold axis in this point group. What about in the direction parallel to the two-fold axis? So, let us see that possibility. So, if I develop a dipole moment in a direction parallel to the two-fold axis, then there is no other symmetry operation, only two-fold symmetry operation is there in this point group, and since this dipole moment is aligned to the two-fold axis, it will remain even after operation of the two-fold operation, it will remain where it is. So, it is possible to develop a dipole moment in this direction. So, we can write this, the dipole moment possible along two-fold axis. So, dipole moment is possible along two-fold axis. Now, consider another related point group, the point group 2 by m, also belonging to the monoclinic system, but now the two-fold also has a perpendicular mirror. In this case, even if we develop a dipole moment, if we try to develop a dipole moment parallel to the two-fold axis, the mirror will generate equal and opposite dipole moment, which will be the mirror image of the original dipole moment. So, here there will be a minus p generated even along the two-fold axis, and they will get cancelled. So, in this group dipole moment is not possible at all, no dipole moment can develop. So, this brings us to this concept of unique axis. So, there are some axes which are unique axes in the crystal, that is, they are not mapped into any other direction by the operation of the group. So, in the example of the point group 2, the two-fold axis is a unique axis, because there is no other symmetry operation which moves this two-fold axis. it cannot go anywhere. But in the point group 2 by m, the mirror plane flips the two-fold axis. So, two-fold axis is no more a fixed direction. Similarly, any other direction, suppose a direction lying in the mirror, will be moved by the two-fold axis. So, those directions also are not fixed. So, in the point group 2 by m, no direction is fixed, whereas in the point group 2, the two-fold axis is a fixed axis. So, what we have to look for is fixed axis or unique axis. So, only point groups which support or which has fixed or unique axis will develop the pyroelectricity. So, point group 2 by m, as we have noted, has no fixed axis, and if there is a fixed axis, on the fixed axis you cannot have a center of inversion, because that will flip the axis. It cannot have a mirror plane perpendicular to the axis, because that will also flip the axis, and a two-fold axis perpendicular to the direction will also make it a non-fixed axis. So, a fixed axis has to avoid all these symmetry operations. Based on this, we come to the classification of polar groups, which are groups having fixed directions. So, only groups having fixed directions are called the polar groups. Here, of course, we saw that a fixed axis cannot have these symmetry operations. Even if it does not have these symmetry operations, if there is some other rotation axis which is inclined to the, it happens for example in cubic crystal. So, if you have inclined symmetry axis to a given direction, that also will not be a fixed axis, because the inclined symmetry axis will rotate the axis which we are considering and will not be fixed. So, finally, we have to look for groups which are having these fixed axes, and it turns out that there are only 10 such groups. The centrosymmetric groups will have no fixed axis. So, we can rule out the 10 centrosymmetric group from the list of 32 point groups I am showing you here. All the 32 point groups in listed in rows of 7 crystal systems. In blue, I have shown the Hermann-Mauguin or international notation, and in black, I have shown their Schoenflies notation. Now, we have seen that the centrosymmetric groups cannot have. Among the non-centrosymmetric group also, the fixed axis is limited only to certain symmetry operations, some certain groups. So, we have seen for example, that 2 has a fixed axis, the two-fold axis itself, whereas 2 by m we have already listed is centrosymmetric, does not have. In 222, for example, in 222 there is a two-fold perpendicular to any given two-fold, and we have seen that if there is a two-fold perpendicular to any given axis, it cannot be a fixed axis. So, that makes 222 also not as a possible group. So, if we find out all the groups which have this possibility of fixed axis, we see that only these 10 groups are possible polar groups which will show pyroelectricity. So, finally, I write all of them again. So, there are 5 monoaxial groups 1, 2, 3, 4 and 6, and then there are 5 groups with mirror planes, M itself, and then mirror plane passing through. Mirror plane perpendicular to the axis is not possible, but mirror plane passing through the axis is possible and gives us the polar group. So, 3m, 4mm, and 6 mm. So, these are 10 polar groups which are capable of exhibiting the property of pyroelectricity. We have not mentioned or discussed ferroelectricity here, but again ferroelectricity can also be shown by only these 10 polar groups. Thank you.